Hello and welcome to this session on using Excel for descriptive statistics. What I have here is a data file and you'll find this available on GCU Learn, and within it we have a whole range of measures. This data is taken from a study where we presented participants with Twitter stimuli. The stimuli were composed of an initial tweet followed by 6 replies, and the replies could either contain a high volume of abuse, that was basically 4 out of the 6 replies being abusive and 2 being neutral, or the replies could be quite neutral, which was typically 4 neutral replies and 2 abusive ones. And what we were interested in seeing was when people are abused online, does it actually impact how the casual observer sees these people? And what we were interested in looking at was social attractiveness. So if you post something and then you get a lot of online abuse because of what you posted, do other people see you as less attractive? Social attractiveness meaning you're less likely to want to be friends with that person. We also took measures of physical attractiveness, which is kind of does what it says on the tin, and we also had measures of task attractiveness. So is it likely that you would want to work with this person? Is it someone you would like to value as a co-worker? We also took measures of victim blame and how severe we perceive the abuse to be. So the data is a little bit messy at the moment, so the first thing I'm going to do is select all by clicking on the grey square at the top and just making sure it's all in the same font. So we'll just go to Calibri and 11, just nice and default. It's also a bit out of order, so we're going to sort it by subject. So we just highlight all our data, data tab, sort, and we want to check, yes, our data has headers, sort by subject. Okay, so what we can go on and do now is we can work out our descriptive statistics, and the particular descriptive statistics we're interested in with this data are means and standard deviations. We have the ratings of social attractiveness across a bunch of conditions here. These conditions were related to whether or not the victim, if you want to think of them that way, had initially posted something that was negative, whether they posted something that was neutral, or whether their initial tweet was something quite positive. And we also had a manipulation of whether or not there was a high volume of abuse or whether there was a low volume of abuse. But you can see here there's actually a mislabel in the data, so let's just change that. So we can overtype and change it to neg low, and that's much more consistent with the labeling of the other variables. So the cells that we're interested in are under each condition. We've got 132 rows, 1 column. So we've got 132 participants in this sample. So what we're first going to do is we're going to work out the mean and standard deviation of this data. So it's always a good idea to label your data. So we want to get mean and we want to get standard deviation. Standard deviation is a bit unwieldy, so we'll just call it SD. And that way we know that these cells are going to represent a mean, we've got them labelled, and these cells here are going to represent a standard deviation. To calculate a mean in Excel, we typically use the equals average command, and as with most commands in Excel, we have to open up brackets and then we have to tell Excel which cells we're interested in. So we're interested in taking the average of the last observation all the way up to the first one, and we don't want the header in. And we get our mean value. An alternative way that we could have done that is using the cell references. So equals average again, and we know that we're in column C, and the last value we want is in cell C133. We can then use a colon, and we know that the first cell that we were interested in was C2. And before we close that off, we can go up and double check. Yep, C2. So a couple of ways to do it, one by clicking and dragging, and one by typing in the actual cell references. If we want to do the standard deviation, we do equals, and the command is stdev, and we open up the brackets, and again we can click and drag to highlight all the cells that we're interested in. We get our standard deviation, or we can do equals standard deviation and use the cell references. So again, we're in column C. We're interested in column C133, or cell 133, all the way up to cell 2 in column C. So we can use the cell references if we prefer. Now the nice thing about Excel is if you've lined up your data systematically and sensibly, as we have done here, we've got every participant's score across each of the 6 conditions. Because that's nice and systematic, what we can do is we can copy this formula and we can take it across. And as you can see, this is now taking the average for column D, the average for column E, F and G. So we've saved ourselves a little bit of work. An alternative way to do this is to hover over that little green square just in the bottom right hand corner of the cell and click and drag. And again, that copies the formula across. Now at the moment, if we make any changes to this data, it's going to change our mean value. So if we for some reason decided to take out these participants' data, you would see that the means update. If we want to protect those values, we can copy the data. We can right click in another cell, we can go to paste special, and just take our values. So the difference here is still a formula that allows your work to be dynamic, whereas down here we've actually protected the values. Now in APA formatting, we typically report means and standard deviations to 2 decimal places. So we can highlight these cells just by clicking, holding down the left mouse button and dragging. Click, hold, drag. Right click, format cells, and number. And we see that by default Excel will give this to 2 decimal places. So to save yourself having to round, you can get Excel to do the work for you.